Example 10. A tank in the shape of a right circular cone of height 5 feet and radius 3 feet with its circular base on the ground, so its axis is perpendicular to the ground and its vertex is pointing up into the air, is filled to a height of 2 feet with a liquid weighing 7 pound cubic feet. Find the work done in pumping the liquid out through the top of the vertex of the tank. Let's try to illustrate the question first. We have a conic shaped tank whose base is circle and vertex is pointing up into the air. So this is our tank with the circular base. The radius of the circle is 3 feet. And the height of the tank is 5 feet. This is 0 level, this is 5 feet. And the tank is filled up to 2 feet with liquid. This is where the liquid is. And the density of liquid is given as 7 pound cubic feet. Okay, this is case 5, pumping liquid out of a tank. So here we need to know density. We don't need gravity because it's not the metric system, so we can eliminate that. A of x, we need to know A of x. A of x is the cross section of the tank. So if cross section of the tank is a circle and the area of a circle is pi r squared. But we need to express r in terms of x. So we can connect the perpendicular height to the radius and we can make up small triangle here, and we can use this triangle similarity. So using this triangle similarity, big height over big radius equals to small height over small radius. So what's the height of the big triangle? The height of the big triangle is the height of the tank, which is 5. And the radius of the big triangle is the radius of the tank, which is 3. Equals to the height of the small triangle, which is orange line here, is 5 minus x, because that's the ith slice. This is the ith slice traveling through the up. This is the ith slice x, and our ith slice x is 5 minus x. So the height of the small triangle is 5 minus x. And radius is what we are solving for. So let's cross multiply. So 5r equals to 3 times 5 minus x. So r equals to 3 times 5 minus x divided by 5. So our all ingredients are ready. Let's place them. So work done equals to integral. So what are the limits of our integral? The limits of the integral is from 0 level up to where the liquid is. So from 0 to 2. Our density is given as 7. Our a of x is pi r squared. Pi times, instead of r, we have to use r in terms of x. So 3 times 5 minus x divided by 5 squared. And our d of x, which is the slice of ith slice which is traveling, is 5 minus x, the height of the tank minus x. So it's going to be 5 minus x dx. So this is how we set up the integral. We can leave the question here. This is how we set up. It's easy to calculate this integral. So let's go to the next question.